Chapter 4, Example 2. Calculation for maximum allowable area loading on the deck. So the first thing we need to do is to calculate the footprint of the container. So they give us the dimensions of the container. So to get the footprint of the container, we take the length times the width, which is 2.2 meters, times 1.5 meters. So we get a footprint of 3.3 square meters. Next, we need to calculate the area load of the container. They tell us that the container weighs 8.2 tons, and we've just calculated the footprint of the container. So we take the weight of the container, 8.2 tons. We then divide it by the container's footprint, which is 3.3 square meters. And we end up with 2.49 tons per meter squared. Now in the question, they tell us that the maximum area load is 1.5 tons per meter squared, so therefore this container is too heavy to set directly on the deck. So now we need to calculate the required area in order to support the container. So we take the weight of the container, which was 8.2 tons, and we divide it by the maximum area load, which in the question says 1.5 tons per meter squared. So 8.2 divided by 1.5, we get 5.47 square meters. So this is the required area in order to support this container. So now we have to calculate the spread of the timbers. So obviously we're going to have to disperse the load over a larger area than the actual footprint of the container. So we take the square root of the required area, which is 5.47, and we get 2.33 meters. So we have to put the timbers 2.33 meters apart. And in this case, if you look at the dimensions of the container, you're going to see that you'll have to crib the actual timbers. Otherwise, you wouldn't get a proper spread. So you're going to need 4 timbers, 2 on the deck, 2 on top of the first 2 timbers, and then the container will sit on the top 2 timbers.